half mark here. Alright, you've already got one, I think. So it's fill first, cut second, is that correct? If you have a look at the latest notes, you'll be able to tell those things that I read out on Wednesday. If you're a surveyor here, you might like to put formation, surveyor and engineer will put formation level. For this one, surveyors might put reduced level. I'm gonna put I have not turned that down. I will turn it down so it keeps on moving all day. So when people ring up that have got unknown numbers, they should leave messages. Okay. Formation level, and the next one below that is reduced level or existing ground. And the next one below that is invert level, which is the pipe invert. And the next one below that is distance. And the next one below that is grade. So, the good news, by the way, that is very rough. I want you to line all yours up, please. All the way down, line them all up like you would have done in English class, okay? So, we do not need any of these cuts or fills all the way along till we get to the platform. Because it is all filled, we don't need any cut under the platform, and we don't need those cuts at the end. We don't need any fills past the edge of the platform where it comes down, so we don't have to calculate any of those. Formation level. Formation level is only under the platform, so we don't need any of those. We also don't need any of those. Existing ground is all the way along. Invert level is all the way along. Distance is all the way along. We don't need any of the grades. We show that quite differently. So this is how we show the grades. We do a dimension from that point to that point, and then we making sure we get the arrow size right, etc. And in here we put grade equals, I'm not going to tell you what it is, XXX, and 1 in XXX. There we are. So you put your grade in that way, okay? Pretty cool, isn't it? Now what I need to do for you is to show you how to calculate some of these distances and levels and things. So, for example, let's have a look at existing ground, say this one here. So there's your ground line, there's your datum. So we quite simply go dimension, linear, from there to there, and we end up with 8.1. So we have a number 40 there. We come down to the ground line, existing ground, and that will be 40 plus 8.1. What does that equal? 48.01.
Yeah, it's 44.44.
Yeah, 44.0.
Dylan, he beat you to it. He's got the half mark this week.
Well, I was just agreeing with him, you know, but
Yeah, that's all right, you can agree. And by the way, it's like, Who Wants to Be a Millionaire, you can give away the half mark to anybody if you want to.
Me as well.
Yeah, no, anyone else.
Oh.
Anyone in class, full stop, all right? But you have to do that before you know your own mark. Yeah. So, you're both right, you've both been following, so it's nice to know two people there are. The problem we've got here is the dimension is double, and we've been going double in both directions. So, how do we do this in AutoCAD to make it a little bit more, I'm going to change that to a by layer.
should we turn the whole thing into a block?
No, there's a much easier way, watch this. By the way, lose it or use it, if you don't email me, you two guys don't email me for that half mark before midnight, you lose it. You don't get a second half mark in any one assignment. So, I'm hoping you two answer all the questions from now on. What we do is we go modify, primary units, and see where it says scale. If we change that to 0.5 and go OK and set current, look what happens to our number up here. 4. So therefore, it's 4 plus that, which equals 44. Technically it's 44.005, but we're rounding to 2, so it's 44.00.
Could you do that again, please?
Dimension style. Now if I click on the correct one here, you have to forfeit your half a mark. I'm just showing you what it is. Can you see it? 0.5.
Primary unit.
What does it say?
Scale factor.
Scale factor.
Primary unit scale factor. So using that same analogy, let's do this line here needs to go right up to the top. We're going to do a formation level. So the formation level for that will be we're going to do a dimension from there to there. 5.4. Go back here, and it's 40, so it'll be 45.4. So where's our formation level is there, it's that one there, 45.40. You don't actually need that row there, I don't know how they're still sitting there. Let's do another formation level. This one here where it touches the edge. Dimension, linear, from there down to here, 4.55. So that'll be 44.55. And let's do an invert level of a pipe, because I told you that it's easy to do that. Let's go dimension linear from here down to the bottom. Notice how we're using 40 as a really nice round number, because we just add the 3.28 to 40 and we get an invert level of 43.28. So for me, who's been using AutoCAD for a fair bit of my life, it's a lot easier than getting out your calculator and grading like I showed you in your lab and doing every single bit along the pipe. I would just do a dimension, and then as I'm looking up those numbers, add them to 40, and that'll be my invert level all the way along. Easy. Right? please delete those dimensions afterwards. I don't want to see any dimensions on anybody's long sections. It just looks really awful, tacky, and it's a clever way to lose marks. The other thing to remember is you're going to need those dimensions again on this drawing for assignment 2, and you're going to need them for your cross sections. So I would suggest when you're finished doing those numbers, delete all your dimensions and go back and reset it. For example, the distances, if I did a distance right now, it won't be right. It's 2.5, right? So it needs to be back to 1 to be the right distance. Because remember, we offset 5 all the time, and the horizontal's always the true scale. So always do all your numbers, all your levels, and then go and do your distances and change it back to 1 again. So there we are. Last thing that I'm going to show you. Down here I've got my existing site plan. It's looking really awful, by the way, but hey, that's it. What you need to do is you get your title block in. You get your titles on here that you want to put on here. This will be sheet 1 of 5. You get that nice even distance around them. If you're filming this isn't good. It probably won't print the very bottom of that. See how that dashed line goes and touches it? So make sure everything's within your dashed line. Make sure it's A1 full bleed, etc., etc. Make sure you've got your logo over here. And then when you're happy, clap your hands and show it. When you're happy, you right click on there and go move or copy, create a copy, and OK. Now you'll see I've created exactly a duplicate of it. And guess what? The title block's there, the logo's there, it's all nice and neat because you made sure it was perfect first. And all you have to do now is change that from saying existing site plan to long section, change the scales, change that to sheet number 2 of 5, and you're there. Oh, not quite there. We go into the viewport, we are going to click inside here. We are not going to use our middle roller like I saw students doing last night. We're going up to the hand of Maradona, and we're going to turn along, right the way along until we find our long section, which is there. Then we go escape. In fact, I'm going to pan a bit higher so that I've got room along the bottom for my notes and my legend. We don't need a locality plan, we don't need the survey coordinates, we don't need a north point. Just notes and a legend. And already there was a note about the manhole, there's a note about the drip line of that tree being a problem, and there's a note about the retaining wall going into the wetlands at this end. So there's 3 brand new notes that won't be on your existing site plan. And when we do our proposed, there'll be more notes, because the butterfly wings are going to touch places you never thought they could. And then there'll be the cross sections that you'll do, which will pick up other issues as well. And if I was, really honest about it all, that's kind of what engineering's all about. It's surveying and engineering. Every day you don't know what you're going. Every day is a different day, and every day is a problem. And you guys wouldn't be doing those two learning about that if you didn't want to solve problems. Simple as that. You can go and do ballroom dancing or serve McDonald's burgers. There's no problems there. Same dude. Call up at the car park. My daughter told me all about them. She used to flip burgers when she was at Unitech. And it's the same old thing. But in engineering, you don't know what you're going to come across, which makes life interesting. Sometimes you go home and you can't sleep because you can't solve the problem. Sometimes you go to work and it's boring because it's similar to the last job, and the next day you go and you've got a brand new job in a brand new don't think you'll ever be rich as engineers, but you never, as long as you are engineers, you'll always